Partial fractions. No, partial fractions, homies.
And that still gets harder.
Is that what you're supposed to do?
No.
Integration by parts?
Oh my goodness.
Hold on, what happened when you guys multiplied?
It doesn't work because
It doesn't work,
it's
It just got harder. It's getting harder.
Yeah, I didn't think it would work.
Oh wait, I don't think partial fractions would work. But what the number 4? But it's. Oh wait, no, you can factor out. You factor out the x. Yeah.
Okay. So we're going to try to do partial fractions because this one, the u and du. My guys in the front, do you agree the u and du is not nice?
Yes.
Yes. Yes.
Do you agree? Okay.
Yes. Did you want this back?
Perfect. You just put it on the stool. Eventually. You can play with it right now if you want. As long as people around you aren't annoyed.
Okay. Obviously Kyle's annoyed, so just keep holding on to it.
He is not part of our group.
So on the bottom I have x times x minus 1 times x squared plus 4. True? I'm seeing if I can figure out what over x plus what over x minus 1 plus what over x squared plus 4. Wait a minute, where'd that cx plus d come from?
Because that's plus the d, which is a constant. So number 4.
Whenever you have a quadratic factor, or technically a cubic that can't be reduced, we call it irreducible, can't be factored further before or without going imaginary. Guys, what's the degree of a linear?
1.
What's the degree of a?
0.
What's the degree of a quadratic?
2.
What's the degree of the top?
1.
You always want to have 1 degree less on top.
Gotcha.
Okay? So when you have a quadratic, you need to allow for there being an x term up top. Now mathematically, how can you think of taking what we know and taking what we need to know and mathematically solving for a and b and c and d? There is a way. What would you do?
X minus x squared plus 4 is top. You just put the ones that aren't there to the top.
What if I erase the integral for a second? Because we're doing pre-cal, aren't we?
Yes, ma'am.
I heard something good, but I also heard other things as well. Why am I putting a multiplying? What would have to happen to each of these guys in order to put them together?
Multiply by the other. You multiply by the other 2.
Denominator. Now I could go through and I could do that, or I could just say, why don't we just get rid of all the denominators? Can we just get rid of all the denominators? If I do it on this side, what am I going to do over here? And I get to distribute. And when I distribute, isn't one of the denominators going to cancel every time?
Yeah.
And have the other 2 left?
Mm-hmm.
So mathematically, if I multiply both sides by the denominator, I get just q minus 4x minus 8 equals. For A, the x cancels and the other 2 stay. For B, the x minus 1 cancels and the other 2 stay. And for Cx plus D, the x squared plus 4 cancels and the other 2 stay. What do you think?
Where'd you get the x plus 1 again? Sorry. Where'd you get the x plus 1? Never mind.
Oh, it's supposed to be d.
Oh, it's a D.
No,
Sorry.
it's not 1.
It's like bx plus
Oh,
c, but it's cx plus d.
Oh, I thought that's parentheses c x plus 1 parentheses.
Yeah, I got confused with that too, but.
Oh.
I did just because right now we're just doing the math of trying to convert, and then we'll put it back in an integral when we need to. So in a way, yes, in a way, no. Excuse me. I didn't really explain that stuff very well. Question.
You have to watch this after later.
Ew. What?
Yeah.
What?
You've been playing with it.
Because you're playing with this. Your hands are all over it. Oh, yes, I think ABers are wanting to go to Burger on the Orient Express tomorrow in Northbridge Mall. Just a heads up.
The what? Oh, we gave them all this tea.
Wait, why?
At like 10:45 in the morning, I think. I don't know, Sean really wants to see it. I'm like, oh, I love Agatha Christie. I know, we'll see.
What's happening in North?
My parents are also coming, so it's my questions? It's Sean Durkin though, he's a champ. Question?
Yeah.
How do we solve?
Simplify.
You substitute, and then you take out the common ones, you set them equal to the whatever you
Substitute what?
Oh, A, so it's AX minus A, then,
Okay.
then you formula that. Then you
From yesterday.
Distribute, I didn't mean substitute. I
Yeah,
distribute.
yeah. From yesterday, we could FOIL everything out.
It's a lot. It is a
We can take everybody by the x cubed term and set it equal to 2.
Yes,
We can take everybody by the x squared term and set them equal to
0.
0.
Yes.
Everybody by the x term, set them equal to 4. Everybody by
A, B, C.
the no more x's term, set equal to negative 8.
Yeah.
But did you guys see how many equations we would have?
4.
How many unknowns?
4.
Woo! Let's get out matrices, right? Anyway, no. Woo!
I like matrices.
Me too. But there is another way. You guys ready?
Yeah.
What if I was to be creative and say for x equals 0 and for x equals 1? Question, if the two sides are equal, if I plugged in 0, wouldn't whatever's left still need to be equal? If these two are equal, shouldn't I be able to plug in x is 0 and whatever's left is also an equation? Why did I plug in 0? Oh, it's like the smallest x. What's it going to do to anybody with an x?
Zero.
It is a gone.
So that's going to be 0. That's going to be 0. This is going to be, well, a times 0 minus 1. 0 plus 4. What's on the other side?
Negative 8.
Ha-ha! I found one. So I can come here and I can say, oh, okay, hold on, let's not put A, let's put 2. Katrina.
Can you not pick 0 because it's not in the domain of the function?
Why is it not in the
domain of the function? Well, because at the top, it's
But I'm just looking at the math, trying to split this guy up, so I'm not really dealing with this function entirely.
Because you just pick it.
Pause. Can anybody explain why I picked 0?
Cool.
No one.
Because it only leaves 1,
Why?
because the other ones will cancel out
Why?
0.
One would take.
You plug in 0 because they have x's.
I picked a 0 of a denominator.
Yes.
So what other one am I going to pick?
Oh, so positive 1.
What other one am I going to pick?
Negative square.
Imaginary 2. No. Imaginary 2. No. But hold on. Look, we got 0 and 1. They're both real. So then if I plug in 1, 2 minus 4 minus 10, or sorry, minus 8, wouldn't that be negative 11? Double checking the math.
Wait, what? 2 minus 4.
Negative 2. Oh, negative 10.
Yeah.
12
Thank you.
plus 2.
What happens when I plug in 1 for anybody with an x minus 1?
That's
0.
0 plus, okay, hold on, plug in 1. So that'd be 1b times 1 plus 4 is 5, right? And then this one's going to be 0. So who's b?
Negative 2.
So I can plug in b is negative 2. Now here's the dilemma. I would love to plug in another thing, another 0 to cancel out, but I can't.
Smash now.
How many variables do I need? C and D. How many x's am I going to plug in? 2 of them. What 2? As easy as possible. What do you guys think? Negative 1, 2, 3,
Negative 2.
negative 2?
Negative 1.
Let's do negative 1 first. And you guys can choose what you want for the other one. Okay, now this is a little bit of a struggle. We're not going to have tons of zeros, but at least it simplifies the process. It doesn't make us multiply everything out and take the cube equation and the squared equation and the single equation and the constant equation and solve a 4 equation system of equations. A system of 4 equations. That's a better way to put it.
Yeah.
Negative 1. Negative 2. Minus 8 is negative 10. Negative 10 plus 4. Negative 6?
Negative 2 plus 4.
Negative 20.
Then I can plug in my 2. 2 times negative 1 minus 1 would be negative 2. Negative 2 and 5 would be
Wait, that's
negative 10, right? I mean, Katrina, you said negative 20, yeah, good. 2 times negative 2 times negative 1 will be positive 2. Positive 2 times 5 will be 10. Negative 1 times c will be negative c plus d. Times negative 1 times negative 2 will be 2, I believe, right?
No, wait, Miss B.
Wait,
The
how-
second
how
time,
the
that's
second-
that's not a 10, that's a 20.
Is it?
Negative 2 times 2 times 5.
Oh, no, negative 2 times negative 1.
Oh, it's an act like that.
So that's 2, and 2 times 5 is 10.
No.
You might have plugged in right.
With the first one.
Start to.
So then that'd be negative 20 plus 10 would be negative 10. Moving it to the other side, I think that'd be 4.
Yep.
What do you see?
Yeah, what do you see?
Wouldn't it be 2 times, no, for the first one, or it's 2 times negative 10, would it be 4 times negative 10?
Let me double check.
Negative 9 minus 1.
2 times negative 1 minus 1 is negative, oh, I went ahead and kept that 2, sorry. And then I did negative 2 times 5 is negative 10.
Okay.
Or it'd be negative 4 times 5 or 2 times negative 10, either way. Negative 20. So negative 20 plus 10, add the 10, that's 4, divide the 2. I end up with, long story short, 2 is equal to negative c plus d. Okay, now we need another one. Have you guys figured out which one to plug in?
0 or 1?
Where do you plug them in? I can't do it again, sadly.
Why can't you just solve for like D and then plug in for D?
Square root of
plus
2
C?
Plug into where though? So you can't plug into itself.
Why not? Why can't
Because
you?
it'll just end up with 0 equals 0, or 5 equals 5. It's gonna end up with true. We have to use another equation. That's why system of equations, we always needed to have 2 for 2 unknowns. So we're gonna do 2?
Square root of 2 over ln of 5.
Yeah, no. Okay, so,
Raise the power of
plug in 2.
16
You guys keep me honest, 8, 16, that's 0, right? Yeah. 16?
Yeah, 16. Yeah, 16. Negative 4 times 8.
Negative 32. And we have, oh, I didn't write the 2 first.
2c. It's 4c plus 2d. 2c plus 2.
Yeah, I see you know it, but hold on. I'll just put it in so people see it.
Times 1.
Because that'd be 2. So that'd be negative 16, add the 16. Then that'd be divide the 2. Right?
Now you add the.
So now we ultimately have a little baby system of 2 equations. So we can go ahead and say that D is equal to 2 plus C, I suppose?
Yep.
Or we could even do elimination, I suppose, if you wanted to do that instead. So you could go ahead and do negative C. That'd be a positive C minus D equals negative 2.
Wait. It's 2 plus C.
I know, I flipped all the signs because I wanted the D's to cancel.
Well, you have all the d.
So I multiplied both sides by a negative 1, so negative 2, positive C, negative D, that way. That'd be 3C is equal to 6. C is equal to 2. If C is equal to 2, plug it in, negative 2, add, D is equal to 4. Hold on, someone double checked me, right?
Yeah.
I did. What was the point of all that?
Just so we can integrate.
Oh, that's right, just to separate it and then be able to integrate it. These 2 came from factors. If I tried to find factors of that, it would be imaginary numbers. So I just had to pick easy things to plug in. I was asking, we could have gone 2 and then 3, but the numbers get kind of big, so then they went negative 1. I was asking if I could random. Anything besides what you've already tried. So kiddos, once we have this, do you guys have the numbers down? You'll keep me honest?
Yeah.
Because I'm just losing it. Oh, I didn't lose the problem, it's right there. So I can say the integral of 2x cubed minus 4x minus 8 all over x squared minus x times x squared plus 4dx is equal to the integral of what over x?
2.
Plus what over x minus 1?
Negative 2.
Plus what over x squared plus 4?
2x plus 4.
Plus 4.
With your mom.
Whew! How do we integrate?
So the first
Come on, it's already been.
2 ln of x plus
Negative
2 ln of x minus 1. But you have to have your absolutes, right?
How do you, but how do you get one cancel? Get one cancel.
Wait, where's the?
Do you use that?
Hard,
Oh, that last
This is a
one's
rough
trig, that's
problem.
our trig.
That's our can right there. That's our can right there.
Oh.
Woo!
She's not getting past me.
Feeling it today, huh?
You'll get.
Alright, Steve, I'm gonna have one equation on one whole page.
Yep.
It's
a good day.
ln. Yeah, it's ln x squared plus 4.
The du matches perfectly, so it's just gonna be ln of. Wait, why am I gonna make these parentheses? X squared plus 4 is always
Positive.
positive. And then this will be arctan of, 4 times, how did the integral of 1 over u squared plus a squared?
1 over
A, which is 2, square root of 4.
arctan u over
Oh,
Which I could make, is anybody gonna have tons of fun with me?
Oh boy.
ln of x
Divided, but then you multiply. Let's see.
wait, no, it's multiple. Oh, is it? I'm out.
Aw, look, he's so nice and cute. Dun, 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 dun. How was that? I don't know, it was a lot easier than I would have, not nicer, pretty clean.
So, what's the chances of having something like this on the AP?
So, is there an easier way to do this? Is that the next slide? Is that,
The next slide is hard.
So, going back to the last slide.
That's the easiest
What
way.
if there's like a really short shortcut that you were just not aware of?
Thank you.
Going back to the last slide. Yesterday, we were talking about improper fractions. You can do long division first. Lost your chance. Improper fractions. Divide first. Proper fractions, aka the degree of the top is less than the degree of the bottom. What are some things you want to think about? U sub, arctan, and partial fractions. One problem had them all. Woo! One problem had them all. Lucy.
where did, put this on our scores.
Did you see where it was,
Say it one more time, Lucy. Sorry.
the simplification?
Take one last round.
We had, integral of 2x over x squared plus 4, and then we just used that from here. How did it simplify to it? I see where the
Oh, because if you had done the u and the du would equal dx over 2x, which would cancel out the 2x, it'd just be 1 over u du, which is went to ln of x squared plus 4.
What do you mean by that?
I did sorry, once I saw that it matched, I was like, oh, du over u. So I just went quick.
Oh, the ln, okay.
Do you see it?
I didn't see that you wrote the ln.
Oh, it's back here, sorry.
Yeah.
Yeah, it's back there.
Thank you.
Okay. What?
You have some random papers in here too.
Wait,
Why do I have random papers? Oh, yeah, I was wondering.
oh, it's in my box. Sorry, no, it's mission trip finance stuff, and I don't even know what that is.
There was some.
The first one's number 4.
Is this for the weekend?
Okay, guys, listen.
Well, we do have a 3-day week.
Here's the deal. Whenever you have quadratic factors like this, there's no shortcut.
That's unfortunate.
Whenever you have quadratic factors like this, like we had over here with the cx plus d, whenever you have a partial fraction decomposition, ooh, that sounds snazzy. A partial fraction decomposition with a quadratic factor, you cannot use a shortcut, but, now pause. So did we look at the hardest type?
Yes.
No shortcut.
Yes.
Well, we did a shortcut, kind of, right? Like we didn't do the whole like multiplying everything in the cube terms, and we didn't have a system of 4 equations that we had to solve. But for the ones that you will see on the AP, in my experience, just put the extras on the table, Brendan. In my experience, all the ones the AP gives you, the shortcut works. And here's the shortcut. You ready? People working, pay attention. Here's the shortcut. If I want to get partial fractions, what you would do for linear factors, you would multiply both sides normally. To do it the long way, you would multiply both sides by the common denominator, true? Okay. When you multiply by that common denominator, you would end up with a times x plus b times x minus a equaling whatever the numerator is. If we were to use my trick from over here, we would plug in for x equals negative b, and we would plug in for x equals a. We would plug in the zeros of both of the denominators. When we plug those in, this will always cancel out. This will always cancel out the other variable. And it'll always give us, plugging in negative b, those would be numbers. It would always allow us to solve for the constant. Plugging in the zero of a factor allows us to solve for the constant above it. Plugging in a zero of the factor will allow us to, on this one, sorry, 1 equals. Will always allow us to solve for. Now guys, the point of the shortcut is not so much that you memorize this math. The point is that you understand the math of multiplying both sides by the common denominator in case they ever decide to put one on without a shortcut. Possibility. But the long story short is, when you look at the original factors, and try to solve, you would end up with, for the first one, 1 over negative b minus a, and for the second one, 1 over a plus b. Now look at this. Ready? Okay. If I was to go here, and if I was to look here, and if I was to say, hey, his zero is a, and if I was to cover up, because if I was to plug in a right now, that would be a 0. But if I cover up that factor, because he goes away once I do my math, if I cover up that factor, guys, plug in a to x, what do you get? 1 over a plus b. Hey! That's exactly where the math goes. Pause. If you look at the 0, what's the 0 of x minus a? And if you cover up that factor, it's called the cover-up method, also known as the Heaviside method, also known as a thumb trick. Heaviside, he was a mathematician that...
The name is Heaviside?
Oliver Heaviside, I think. It's spelled with an I, not with a Y. Plug in A.
That's so funny.
Plug in A.
1 over a.
1 over
1 over a plus b. Got it. You would solve for him. Now, pause. Who's his 0 of the denominator?
negative b.
Cover up the x plus b. Plug in negative b. 1 over negative b minus a. Got it. That's where the math would lead you. And you don't have to do any of that.
Yeah, but that only
So, that only works on
x
any
minus...
partial fraction integral I've ever seen the AP test on in these. Now, I showed you the other method in case they ever give us a harder one with a quadratic factor that's irreducible. But the only ones I've seen, this method works.
What about like in the one we did when it's an x? When your a or when your little a or little b is an x.
Little a or little b is an x.
Like that's the one we just did. It was x squared minus...
Oh, no, I just said, yeah. Whenever there's a quadratic, the trick doesn't work. So we did the hardest part all the way through.
Gotcha.
But if there's only linear factors, then we're golden.
Gotcha.
Kiddos, can I have you go ahead and, let's not do this one, you guys don't need to see the common
Yeah.
denominators get something. Write down this partial fraction. We'll get back to logistic growth in just a second. Write down this partial fraction. The integral of x minus 13 over 2x squared minus 7x plus 3. Question, why not Yusuf? Okay, Jason, no, hold on, I want you to see the shortcut. What wouldn't cancel?
The 13 is...
Because du would be 4x minus 7. Wait, can I even like, ooh. I could add and subtract, but how am I going to get the 4?
That's killing a kitten.
Yeah, I'm going to have some issues. can have some issues. If it was something like, I don't know, 2x minus 26, I can deal with that. If it was even like a 4x up here, a 4x minus 1, I can deal with that, but I can't deal with 4x minus 7, or
Part
can I?
method.
Part method?
No. No way.
But then you'd have to you'd have to complete the square.
Pause. You guys got scared by the 4x minus 7, but maybe you shouldn't have.
It's 7x plus 3.
What would I need to do? What would I need to do in order to make these match?
We convert the 13.
Can I multiply by 4 over 4?
Yeah.
Is that legal?
Yeah. And then you can split up the 4 times 13, 15, so that's negative 2.
So I would have 4x, and I have, technically this would be 4x minus 52.
Mm-hmm.
Couldn't I take 7 away from that?
Yeah.
But how much is left beyond that?
45. Is that over everything?
What?
Minus 45.
Yeah. Sorry, I hadn't gotten there yet.
And then you can split
I can split up the integrals, and I could say, okay, this one's going to be, hey, isn't this going to be u du, or sorry, du over u?
Yeah.
So I could do 1/4 ln of, okay, don't be scared if they don't match up. If I have an x term and a constant, and if du has an x term and a constant, I can play around creatively
Wait, you want
to make it match. It's going to be du over u, right?
Don't you have to do...
I could pull out the 45. Let me pull out the 45. Yeah.
Do you have to like complete the square?
We could try.
Will that not be...
If we try to complete the square, because then Katrina's being like, maybe it's just arctangent. So if I was to pull out a 2, I would have the arc squared minus 7 halves x plus 3 minus. I'd have to cut 7 halves in half, right? 7/4. I'd have to square it, 49/16. I'd have to multiply it by 2, 49/8. But wait, 3 minus 49 and 8, that's like 6-ish, right?
Yeah.
3 minus 6, why am I going to say don't do arctangent?
That's
That's going to be a u squared minus an a squared. That's not arctan. So can I do arctan? No. It was a good idea. Sometimes maybe you could. So what am I going to do besides arctan? Once again, u squared minus, if there's a negative, it's not going to work. I'm going to factor. What do we got, cool kids? Please tell me we can factor.
You have to do that.
That works.
We have 2x and x, right?
Yeah.
And then can't we do a 3 here to make a 6x? And a 1 here to make a 7? With a negative and a negative? Is that okay?
Yeah.
Okay. Now, here's a dilemma. I have to look at this partial fraction and try to decompose it. But let's see if I can do it without Liz showing much math. You ready? Okay. Cover-up method, heavy-side method. Ready?
Mm-hmm.
Who am I covering?
X minus 3.
What's the 0 of what I'm covering?
3.
Okay, hold on. Eyes on me, eyes on me, eyes on me. What am I covering?
X minus 3.
What's the 0 that I'm covering?
3.
Plug in 3. 1 over 2 times 3 is? 6 minus 1 is? 1/5 goes above the x minus 3.
Wait, I thought I had
You go above what you cover. What I cover, I'm looking for the b, because the x over 3. What I cover, plug it in. 1 over 2 times 3 is 6. 6 minus 1 is 5. Well, that's a little bit nicer than multiplying both sides and having to then simplify a system of equations. What about the other one? Cover 2x minus 1. 1/2. Plug it in. What's 1/2 minus 3? 1/2 minus 6 halves. Negative 5 halves. 1 over negative 5 halves. Negative 2/5. Plug in a 1/2. 1/2 minus 3 is negative 2.5 or negative 5/2. 1 over says flip it. What can I now do with the 5th?
Take it out.
Pull it out. 45 over 5 would be 9. And that's being multiplied by the integral of, I could call it a negative, that doesn't really matter, negative 2 over plus 1 over. I need some ln's and be careful with the u sub, but I'm almost there, cool kids. You see it? See it? This would have to be a u sub, right? U would equal 2x minus 1, so du, don't I need a 1/2?
But then it'll cancel each other.
Okay, so the 1/2 and the negative 2 can cancel, this negative will come out, that'll be 9/4. I need a 1/2 because of my du. That'd be ln of 2x minus 1. The negative times the negative is a positive, the 2's cancel, good. Then I'm going to have distribute, 9/4. Do I have to worry about du? No, he's good. Du, I needed a 1/2, and the 1/2 and the 2 cancel. Just in case others don't. The 2 and the 2 would cancel. Plus C.
Simplify.
I hate this section.
Wait, I thought the cover-up method wasn't too bad though, was it?
No.
It's the easiest
Still
one,
done a
it's
lot of
still
work,
the
but
hard
I might
part.
put that all in one line in the homework.
Well, you don't have to put it in one line. You can go ahead and make like 4th roots and 9/4 roots, and then you can go ahead and multiply and divide.
The whole thing.
Oh, party pooper. All right, so
Because I'm actually a line and a half. Like,
it's all on our heavy side. Not so much on the heavy side. Heavy
It's
side.
not a bad size.
Yeah, right? Because it wasn't a nickname, it was his main name. You guys are so mean. Anyway, he came up with the whole idea of the cover-up. We're not going to do another one, but you don't need to write all this down. But it's time for us to transition to logistic growth, or logistic functions. We've done the partial fraction part, now it's time for logistic growth. So if I were you to go ahead and in your notes write logistic growth. We're done with partial fractions for a while, until homework.
I have a question.
We already kind of talked about this idea yesterday in our book, something very similar. They're saying, imagine if the human population growth went unchecked, we'd have people covering every square inch of the Earth and the galaxy and the universe. Imagine trying to find a parking place, yeah, okay? Another way of thinking about it. Does it make sense naturally that gazelles in Africa will keep on reproducing? That was yesterday's example, right? No, because as there become more and more, how quickly can the whole herd be running from the predators?
Not very good.
Right? So just naturally, as they get bigger and bigger and bigger, an environment is only meant to really sustain a certain amount. And either then all the resources as far as their food will get depleted, and so they're going to start starving, or the predators are like, oh, they're easy prey, so we can go get them because there's so many of them. So the idea is that just naturally things are held into check, and so that's the idea once again. Things can grow exponentially for a while, but eventually they'll have to start limiting off. Or I should say, leveling off towards a limit. So, right down here is what I need you guys to write. Logistic growth has the differential equation dy dt, where y is a quantity, equals k times y times L minus y. And that results in a y equals f of x that has, you don't have to write about the rumor and all that stuff, they gave us another example, but it has the general sketch of starting at some sort of initial, which might be 0, I mean, depends on what's growing, usually like a 1 or a 2 or a 5. It does grow exponentially for a while, it has a point of inflection, then it starts growing less rapidly as it comes off towards the limiting or the maximal sustainable population. Gabby?
Is this still part of,
Yeah, still 7.5 is like part 2. So partial fractions, we just kind of finished, and now we're going into logistic growth. You'll see the tie-in in just 1 second here.
So do we make it 7.5?
If you want. If you want, you don't have to, but if you want. Did we make it 7.5a for the first one?
Yeah.
Bummer. Yeah, just take off the A and just call it partial fractions and logistic growth if you want, or some of you have already made a 7.5b, that's fine. However you put your table of contents, I'll take. If you would rather totally separate them and do an A and a B, that's okay. But if you've already started writing on, keep it, just make it 7.5 and name it partial fractions and logistic growth. Does anybody see why we needed partial fractions? What do we do with the differential equation? We integrate. What would this differential equation separated look like? You can get rid of all of these. Ah, there we go. This is the one we want. Logistic growth. We already talked about partial fractions, we need those extra slides. Logistic growth. If this is logistic growth, and if this is supposed to result in y equals f of x, or that could be the f of t, for some sort of quantity, we're trying to separate the variables. So we're going to have k times dt on one side. But what's on the other side?
Isn't K constant?
Uh-huh. So it could have gone, but usually we try to leave everything on the x side as possible. How do we integrate when we have two factors in the denominator? The limiting constant is the limit. It's the maximum sustainable function. It's the limit. Yeah, the constant. U sub, that's yucky though, it's going to be a 1 minus 2y. I don't have it. Partial fractions.
Yeah. Well,
Come on, there had to be a point for the partial fractions. Why don't you do it, besides the fact that AP tests on it? Pause, it's not that bad. Cover up. You have a 1 on top, right? I'm covering up the 0, y equals 0, right? Covering up y equals 0. Plug in 0. What's 1 over L minus 0? And covering y, which means plug in 0. What's 1 over L minus 0?
1 over L.
1 over L. I'm covering up this factor with a 0 of L, right? Plug in 1 over L. So what can I pull out?
1 over L.
Second one, when I cover the 0, I need to subtract the L and then divide by a negative 1. The 0 is L, so plug in 1 over L.
When you write that, I can say, like, you cover it up.
I set each factor equal to 0. And so when I go to cover the factor, I plug in at 0 to the y spot. So 1 over L minus 0 is 1 over L. When I go to plug in L for the other one, when I cover that factor, 1 over plug in L. Now I can go ahead and pull out 1 over L. I think you guys see the U sub isn't too bad, right? Let's see if you follow. It's going to be ln of y minus, why is it minus? Ln of L minus y.
G is negative.
Yeah, U is negative 1, so I have to offset by a negative. Now hold on, is there a property to put those two together?
Yes.
So ln of y over L minus y. Oh, can't I multiply L to the other side? Okay. If I multiply L by KT, if I multiply L by one arbitrary constant, can I just make it a new arbitrary constant, C2? How do I get rid of ln? E. This is all in the exponent. Wait a minute, what can I do with the plus C?
Right from.
Good. Are you guys tracking if I divide both, or multiply both sides? I have to somehow break this up. So y equals, I can distribute, it'd be LCE to the LKT.
What happened with y?
Hold on, sorry. Yeah. I have to do that because don't have to get the y's on one side. So I can get y plus,
So let's see one number.
well, I can pull out a y once I move it, right? So So y times 1 plus CE to the LKT equals LCE to the LKT. Then I can divide. I added this to the other side, and I factored out a y. I added this to the other side, and I factored out a y. Now, this is, it's a pretty good equation. It's not too bad, but do you see how to use this LKT? Do you see how there's kind of one on top and bottom? If I multiply by 1 over CE to the LKT,
Why am I writing this down?
I would get y equals, these reduce, L all over. This would have 1, that would cancel. I end up with 1 from this one, they cancel out, plus CE to the negative LKT. My question to you is, how fun was that integration?
Not.
So fun.
Good thing there's a way to memorize it. You ready? Logistic growth. Lice minus licked. L-I-C-E. It's not true. You're so cute. Minus L-K-T.
Lice.
Lice minus licked.
It's a way to remember.
Or really fond of integrating that. But the cool thing is,
It's like full tongues in it.
it will,
That's so gross.
mental picture will stick. Lice minus licked. You've seen the picture long enough. We've already written that down. This is the page that you're going to want. Differential equation. It actually can show up a couple different ways. I might do another variation of the differential equation. We have this. General solution, lice minus licked. I don't have to ever solve that. You wouldn't have to ever solve that differential equation again. Praise the Lord, yeah? We know a few cool things about logistic functions, like as I go to infinity, it has that limiting constant. If I write it in the right way, it's just that top number I get to steal. And it's always going to be increasing the fastest when that limiting constant is cut in half, hence how I was able to school all the guys yesterday. You guys do have that AP packet. It won't be due until Tuesday. Section 7.5, double check the calendar. We have more examples to do on Monday. I'm having them both due Tuesday. Sound good?
Will this be that one covered because I don't want that.
It's going to be... Michael gets...
Yeah, let me freeze this just in case. Okay. Going back, right? Yeah. No one. That one. So what? The ability to separate the 7 and then...
I took the 52 and I said I only need 7. So I said negative 52 is negative 7 and I subtracted, and negative 45. So I could have written them next to each other, but I could also just split up with a common denominator.
Oh, so that's how it's legal because it's still equal. Make it.
I just said I wanted the 7 only, so he went and then the other one.
Yeah, I know.
Well, the nice thing is,
Third paragraph.
I showed you some really hard stuff today, but what you need for
Like,
your
I'm not keeping up at all.
Oh, like what I'm doing.
Yeah.
Just do you have a rubber band?
Yeah.
But I did show the harder ones.
Okay.
Huh? A rubber band?
I think there's one on the front table, if I'm not mistaken, on that
That was
paper bag.
easy for you.
Do we get our test back
I read 2 pages.
No, Doug.
What was your exam?